Hello all, welcome back again to the series of Network Security Essential. In this session, we will see cipher feedback mode. In this mode, each ciphertext block gets the feedback into the encryption process to encrypt the next plain text block. So some rules have been given here. You can read here, but see, a very simple algorithm. Only you have to remember few steps. In first step, as mentioned, we are loading the initialization vector into the top register. So let's consider this is the top register, and this top register, for example, having some blocks. Okay. So in this particular register, initially we are loading the initialization vector. So this initialization vector is any random value that can be added into the top register. This is the top register. Okay, top register. And so size of this initialization vector is a n bit. Okay, so remember this keyword n bit size initialization vector is used in a top register. Now whatever initialization vector is there, just apply encryption algorithm in the second step. Encryption algorithm here we have to apply. How to apply encryption algorithm? So here we are using some keys, right? And afterwards, here as mentioned, we are getting the n bit because initialization vector is size is n bit, and encrypted size value is also n bit. Okay, so after encryption, the next step is that just select the similar most significant bits from the left. Okay, so in the third step, here we have mentioned take only yes number of most significant bits left bits of the output encryption process. So here whatever encrypted data is there in the form of n bit, just select the which bits most significant yes bits. Okay, so those yes bits. So here, what is the size of yes bit? 1 is lesser than yes is lesser than n. So size of yes bit must be there in between 1 and n. Okay, so whatever n value size is initially added into the top register, which should be equivalent to the yes bit. So that is why in the third step we are selecting the most significant yes bits. Okay, because the size of n bit and yes bit will be dissimilar. For that purpose we are selecting the yes bit. Now in the fourth step we are applying XOR function on yes bits. So here we have selected most significant yes bits, left yes bits, right? So those yes bits will be XORed with the first plain text. First plain text. Because as we know, we don't know the size of plain text. As per the size, we can have the first plain text in the fourth step. So that first plain text will be XORed with the S bit. And after that, we are getting the outcome. What type of outcome we are getting? We are getting the encryption outcome, that is our first ciphertext for the first block. Okay, now see, in the second step what we are doing, in the second step here whatever output we have generated in the last step, so that value we are just adding. Okay, so the some blocks are there and initialization vector was there in the first block. Now this output we are adding into the block, but where to add? So here in this purpose we have to shift shift the blocks, shift the block from right to left. So whatever initialization vector were there, so it will be shifted into the left, and then we will add the ciphertext 1 into this block. Okay, and same procedure we will follow here. N bit will be again added for the next step, then encryption along with the key. Then again we will select the n bit here, and then from the n bit we will select the most significant yes bits, right? And After selecting S bit, that S bit will be XORed with the second plain text. Okay, and finally we will get the ciphertext 2. So this process we have to follow. Okay, up to when? So we have to follow till all plain text blocks are processed. So whatever plain text blocks are there, if all blocks are completed, then we have to stop the process. Now just tell me, this last outcome will be there in the next step. So whatever value is there, so we will shift into the left. Again, n bit will be encrypted. Then here key will be applied for encryption. Again, select the MFB. So same step, whatever selected S bit is there. So XOR with the third or third plain text, and we will get the third ciphertext. So this is the process of encryption. Now here we have to remember one thing only: whatever value we have encrypted, so that value will be shifted into the top register. Okay, so whatever output we have generated, that output will be shifted into the top register. So shift the block to the left. Okay, now what about the decryption process? So decryption process will be like this. For example, here same process we have to follow. Here also in a first step we have to add the initialization vector for decryption as well. So here I will write decryption. Okay, now the size of initialization vector is, as we know, n bit, so that will be extracted. We will apply what to apply here. The process is of decryption, but remember that while decryption also, here we are applying the encryption algorithm. So that this is the beauty, or you can say the dissimilarity of this algorithm. Don't apply decryption algorithm here in the decryption process, but apply the encryption process, and we will get the what, n bit encrypted value, right? That n bit encrypted value will be XORed. How to XOR? So again, select the most significant left bit, left bits. So finally we will get the S bits from this one, right? And now after getting this one, apply the formula. Which one? XOR. Here what we have to do, instead of plain text, you have to add the, you have to give the ciphertext first. Okay, for a first step, and then we will get the plain text first. Getting my point? So this is the process of decryption. Now see, what about the second block? So this output, plain text output, will be given to the next step. So here in the first particular top register, whatever initialization vector value was there, so that value will be shifted to the shift left, right? And whatever output, whatever plain text we have generated, just add into the this top register, and again follow the same. So n bit, then here encryption along with the key, then again n bit we will get, and after getting the n bit, so select the MSB, just choose the S bit MSB and apply the XOR. With whom? XOR with the ciphertext 2, and finally we will get the plain text 2. So this process will be continued till all ciphertext gets over. Okay, so that's it. Thank you.